Networking, TCP/IP ports and protocols. TCP/IP was revolutionary in that it allowed routing and it allowed us to start communicating data over long distances because it allowed for different routers to sort of send that data onto another router, and so on and so forth until it went to another server and then back to you. However, there were other protocols that allow us to do the bulk of what we're doing over that TCP/IP. So what we're going to talk about are some of those protocols that you need to know for the A+ exam that allow services to occur, such as browsing the internet, sending email. TCP/IP enabled them to work on top of them, but we still have protocols that use these technologies in order to make it all work the way we want. And then we're going to talk about ports involved very heavily in this discussion, because there are certain ports you need to know for the exam, and ports are the logical endpoint of one of these protocols. So when a data packet reaches a computer, it needs to know what to do at that point. Where do I go? Who am I looking for? And that's where the port comes in, because it can say, oh, I'm looking for port 25 on this computer, for instance. And that'll tell the computer what it is this data packet is meant to do. So we're going to talk about those, and there's a lot of text in this one, so I want you to pay careful attention. I'm going to point out what you need to know, okay? And some of these you might know. So first we're going to start with talking generally about ports and what they are. There are two types of ports. Every port number, there are two types. There's TCP and there's UDP. We're going to talk about the difference between them, although you won't have to necessarily recognize whether something is a TCP or UDP port for the exam. Then we're going to look at several TCP/IP protocols. Some of these you've probably heard of, and for each of them you need to know the port that it's by default given, or that it works over. So we're going to talk about FTP, which is 20 and 21. SSH, or the secure shell, which is 22. Telnet, which is 23. SMTP, allowing us to send emails, 25. DNS, what allows us to browse the internet because it changes google.com into an IP address number, that's 53. HTTP, which is the protocol allowing us to browse the internet. POP3, one of the protocols that allows us to receive emails. IMAP, which is another protocol for receiving emails, although works slightly differently and has taken more dominance in the field. HTTPS, a secure rendition of HTTP that allows you to search the internet. RDP, finally, Remote Desktop Protocol, which we have looked at when we were talking about Windows, allows us to remote into a computer. Then there are some additional protocols that you don't need to know the ports for, and by the way, I've been writing these ports out, the port numbers, just because I want to keep repeating them, and I will repeat them later, and then I'll give you a table as well. And some of these additional protocols are DHCP. What we've discussed allows a server to allows a server to assign an IP address to a computer. SNMP, used for managing devices. SMB, which is what allows you to share out printers and files. And LDAP, which is our directory protocol, allows you to log in using a username and password, for instance. All right, so let's start talking about TCP/IP ports in general. In a sense, a port is the logical endpoint of a connection. So we're not talking about a physical port. That would be sort of like the connection. Okay, what we're talking about is a logical port, a logical endpoint of a connection. So if I have an IP address, 192.168.1.120, there will be a colon and then it'll have a port, colon 80, which is telling the computer that this data packet is meant for something on port 80, which turns out to be HTTP or web browsing. The IP address defines the node, but the port identifies what to do with that information once it reaches the IP address. Again, getting to the computer is one thing, knowing what to do with it once it gets there is a whole other. In TCP/IP, ports are either what we call connection-oriented TCP or connection-less UDP. We'll talk about what the difference is between those two, but just remember, connection-oriented is TCP, connection-less is UDP. For two computers to communicate, they both have to use the same protocol, which generally dictates which port is open on the network adapter. So I know from my firewall that I have to open port 80 to allow web browsing. If port 80 is closed from traffic coming in, I'm not going to be able to browse. So it allows us to use a sort of shorthand, so that way everyone in the world knows where they're going to be communicating through. There are three ranges of ports. Ports 0 through 1023, which most of the port numbers we're going to learn fall in, are what are called well-known ports. These are sort of industry standard ports. They do not change. 1024 through 49151, we're going to see one in this range, are registered ports. These are literally registered with an international organization. Say Quicken would want to register a port so they can use it with their software. And finally, we have what are called experimental ports. These are private. They cannot be registered. They can only be used in a private realm, not outside, not publicly over the internet necessarily. Okay. So first, TCP. This stands for Transmission Control Protocol. And remember that control. This is known as a connection-oriented session. So any port that's any TCP port is connection oriented. This means that every packet that is sent is checked for delivery. So, like a delivery confirmation when you're sending something through snail mail, it doesn't just send it and then hope it gets there. It sends it and then it checks that it definitely got there. If the receiving computer doesn't receive the packet, it knows, because it's TCP, and then it can ask for the packet to be sent again. So in this way, TCP is going to make sure that you get all the data you got. And if you didn't get it, then it's going to say, hey, I didn't get this packet. Can you please resend, to make sure that you do get it? So it's not going to leave any gaps in the data. All right, no one packet is left behind. UDP, on the other hand, stands for User Datagram Protocol. And a datagram, by the way, is a sort of another name for a packet. These are known as connection-less sessions. Basically, if the packet is dropped, we're not going to ask for it again. I'm going to let it go. So whereas TCP is going to say, hey, I didn't get a packet, UDP is going to say, hey, don't worry about it. You lost a packet, but I'm not going to need it. This is like sending mail over snail mail, but not getting a delivery confirmation, or not having someone call you. So you don't know that it got there. You're just sort of hoping that it got there. This is used mostly in streaming media. The reason being, if some data doesn't get there, then I have a skip in the music, but I want it to keep going. I don't want to have to send for more and then I have to pause the music while the music comes. It doesn't work out that way. So UDP is good in situations where I don't need to make sure I got all the information. So music, video, etc. These are certain instances we're probably going to be using UDP ports rather than TCP ports. All right, let's talk about some of the protocols that you need to know for the exam, and I've chosen the specific ones you're going to get asked on. First, FTP. This stands for the File Transfer Protocol. For lack of a better way to say it, this allows computers to transfer files back and forth. So when I want to upload some files to someone, I log into their FTP server, and then I can upload files to them, and then they can send files to me. Most of the time when we download files, we download it using a slightly different protocol, but FTP was the original protocol used to send files back and forth. You usually connect using TCP/21. Sometimes you will also use TCP/20. Now notice it is TCP because I want to make sure if I'm sending you files, you're getting the full file. I also need to make sure that I have an FTP client software necessary to connect to an FTP server. So you use a program such as FileZilla or CuteFTP or one of these programs you can download for free off the internet. You type in, it asks for the server, and then it'll ask you for a username and a password, and you type that information in and it logs you in. Sometimes it'll ask you for a port. By default, it's either going to be port 20 or more than likely 21. However, it's important to know that by default it's going to be these. You can always change them, just like almost any of the ports we're going to talk about. TFTP is another one to know about. This is trivial FTP, and it uses UDP 69. So whereas I'm using a TCP port here, and I wouldn't worry about memorizing this necessarily, but I want to mention it just in case it comes up in the exam, trivial FTP uses UDP 69. It's not positive that the data is going to get there, but it doesn't really matter because this uses a lot less resources. So in certain instances, I might be using trivial FTP as opposed to regular FTP. There's also a different form of FTP we'll talk about in just a second. So the secure shell, or SSH, allows data to be exchanged between computers on a secure channel. So, for instance, if I'm going to deal with credit card information, I'm going to want to use secure shell. It also offers a more secure replacement to FTP and Telnet. So if I'm going to connect between two computers, instead of using Telnet, which we're going to talk about in a second, I can use the secure shell. It creates a secure user shell over a network for me to communicate with another computer. We can also use SFTP, secure FTP, which is going to run on this port, which is port 22. So we're going in order here. FTP first, then I can use 22. SFTP is going to use 22. Also, secure shell is going to use 22. A really good rule of thumb, by the way, if they ever ask you which of the following is not secure or is secure, the one with an S in it is probably secure. There's also an HTTPS, just like there's an SFTP. All right. Telecommunications network is sort of a legacy, older protocol. It stands for telecommunication network, and it provides remote access to other hosts in the command line. So nowadays, when we access computers remotely, we're using a graphical user interface, a GUI, and we'll generally connect, by a RDP or something. Telnet was one you would use the command line to establish a connection, and it uses TCP 23. Okay, so again, we're going in order here. It's mostly not used anymore because other protocols do it better, frankly. But this is an older form. It didn't encrypt the data, the password. So the password would be sent over, the network, and anyone who could sort of pick up a packet could see it. So it wasn't very secure. SSH, on the other hand, much more secure, so it's used in a lot more circumstances. So it's been replaced mostly by SSH. By the way, it may still be used to access some routers and other hosts on your local network, which is the reason we bring it up. All right. Now we're getting into some stuff you probably have seen a bit of. SMTP, Simple Mail Transfer Protocol. This is what allows you to send email, for lack of any other definition. You can remember this if you want with send mail to people. Okay, I don't seem to have a problem remembering just SMTP or Simple Mail Transfer Protocol. It could be because I've been doing this for so long. It commonly uses TCP 25, but this must be a local server. Meaning, if you are on, let's say, Verizon provides you your mail server, provides you internet access, rather, you have to use SMTP 25 for their server. If you try using SMTP for Google's server, it's not going to work because they're not local. So 25 must be the local server. If you're on the Hilton internet because you're traveling, you must use their server. You can't use your server from home, and this sometimes causes problems when people travel. Okay, so what you generally do, you have to use your ISP's SMTP server, and in many cases they use what's called an SMTP relay, which allows you to send the email through someone else's server instead of a local server, such as Google, and that's going to use TCP 587. All right, so generally speaking, if it's a local server, it's TCP 25, but nowadays, a lot of the time, they're doing it through an SMTP relay, which is TCP 587. And good to remember and to know. Domain name system, or domain name service, sometimes called, used to translate domain names to to translate domain names to IP addresses. So it is going to translate google.com into whatever the IP address is for Google. It's, and there it is. It uses UDP 53. Okay, this is not data we need to worry about. I don't want to spend the extra resources making sure it gets there. So I'm going to use UDP, a connectionless protocol, and it uses 53. The Hypertext Transfer Protocol transfers web-based materials from the web server to your web browser. So it is what allows browsing. That's why you always see http://www. Normally, it's done in a compressed format, not in a secure format. So in order to make it go faster, you're working in not a compressed format. It's not secure. People could see what you were browsing if they were looking in. It uses TCP 80 by default. However, sometimes this changes, and sometimes you're going to use more secure methods of this, HTTPS, which we'll talk about, in order when you're dealing with, say, credit card purchases or something over the internet. The Post Office Protocol version 3. This is used by email clients to retrieve incoming email from a mail server. So what this does is it downloads the mail to your client and either removes it or leaves it on the server. Either way, it doesn't organize anything on the server. So when you read something on your smartphone, it does not show as read on your computer. POP downloads the email. This is an important distinction between POP and the next one, IMAP. It downloads mail onto your computer, but it does not organize it. So once it downloads it, it doesn't update the server. If you download it and then delete it, it's not necessarily, although you can set this, it's not necessarily going to delete off the server. If you want that, which is a little more advanced, you're going to use IMAP, which is the next one we're going to talk about. So nowadays, IMAP is more prevalent because if I check it on my iPhone, I want to make sure it's checked on my computer. This, by the way, uses TCP 110. You're going to want to remember that. TCP 110. IMAP, the Internet Message Access Protocol. This is an email protocol that enables messages to remain on the email server, so they can be retrieved from any location, and it supports folders, so you can organize them into folders. So instead of downloading the email onto my computer, I'm caching it onto my computer. I'm creating a copy on my computer that I can read, but every time I do updates or delete something, that change goes back to the server. So when I read it on my smartphone, it shows as read on my computer. When I delete it on my computer, it shows as deleted on my smartphone. This, by default, uses TCP 143. The Hypertext Transfer Protocol Secure. We talked about HTTP, which works on port 80, okay? But HTTPS sends and receives information like HTTP, but it's more secure. It has what's called Transport Layer Security, TLS, which we'll discuss more in Security Plus and a little bit in Network Plus. And this encrypts the information as it's going through the browser. This is used for credit card transactions, etc. And if you Google browse nowadays, you can use HTTPS google.com, which you might want to do if you don't want people sneaking and looking on your browsing. It uses by default TCP 443. The Remote Desktop Protocol, the last protocol I want to talk about, it allows remote computers to have full remote control of a PC. So it's going to allow you to log into a Windows-based computer from another computer. Does not have to be Windows-based. You just have to have the remote desktop client, and it allow you to control that computer. Users are given limited access to a remote computer's applications. So you don't necessarily have full control because you're not sitting there. So an administrator can decide how much access is given. Don't forget, administrators are always given full control to a computer. And this is also the same thing, although we would call this remote assistance. This also allows you to invite people to access and help you on your computer, say your grandmother. This, by default, uses TCP or UDP port 3389. Okay? Because, again, lag is something we don't want. It's probably going to double it up. All right. I put this port chart on the right here because these are all the ones you need to know. If you remember this chart, and I'm telling you, memorize this chart, you'll get, I would say, 5 to 10 questions off of this at least, if not more. First thing you do when you walk into that exam space is write this down on your brain dump sheet. That way you don't have to think about it. You don't have to recall anything. You have all of these. FTP, 20 and 21, SSH 22, Telnet 23, SMTP 25, DNS 53, HTTP for browsing 80, 110 for POP3, IMAP, more advanced email 143, HTTPS 443, SMTP specifically the relay, which I put a star next to 587, and RDP remote desktop protocol 3389. Remember this chart. I think it should be on your notes as well. So we've now talked about ports, including connection-oriented ports and connectionless ports. We also talked about protocols, FTP, the file transfer protocol, SSH, the secure shell, Telnet, which allows remote access, SMTP allows email sending, DNS allows Google to IP address, domain name system, HTTP allows web browsing, POP3 allows you to download your email, IMAP allows you to organize your email, HTTPS, secure HTTP, and RDP, remote desktop protocol, the only registered port we're going to learn. Remember these ports and you'll be good to go. Now, before we finish up this video, I just want to talk about quickly a couple other protocols that you don't necessarily need to know the ports for, but will pop up on the exam. And by the way, all of these ports will be repeated on Security Plus and Network Plus, so it's good to memorize them now. All right, Dynamic Host Configuration Protocol. We've talked about this already, but this automatically assigns IP address information to hosts, such as computers, printers, servers, routers. It'll automatically assign the IP address if it's configured to be dynamic, not static. And what happens is it not only adds IP address, because that is the main thing in IP address information, but it's also going to give us our subnet mask, the gateway, where the computer goes if it doesn't know where else to go, and DNS servers. So all of these are assigned automatically thanks to DHCP. And remember as well that a Soho router has a DHCP built in. So it can assign IP addresses to computers. You don't have to buy another device. And there it is. If the IP address is assigned, you cannot count on it remaining the same, although sometimes it does, because you apply for a lease to an IP address, and sometimes that lease expires. Once the lease expires, it's no longer good for you. All right, so when your computer logs on again, the server, the DHCP server, is going to give you a different address. DHCP allows this all to happen. The next one I want to talk about is the Simple Network Management Protocol. It's used as a standard for managing and monitoring devices on the network. So the network management system controls everything SNMP based. And what I mean by this is it's installed in your computer, which is known as a manager, sometimes a server, and the devices to be monitored are known as managed devices, say a printer or a router or something that's sending out packets. What it can do is the printer can send out a packet that says, hey, I'm out of ink or I'm out of paper. And that is picked up by your manager, the NMS, and on a big enterprise network, we have one manager that's doing this, and we have lots of devices it's checking. These include routers, switchers, computers, printers. All of this stuff uses SNMP and can be monitored by it. And in an enterprise setup, you can imagine how much energy this is going to save if I can centralize all of the management of all these errors that are coming out. Server message blocks provide access to shared items on the network, such as files and printers. SMB, which in Linux talk would be Samba, another version of SMB, allows you to share files on your network. It also provides authentication, so you can make sure only the people you want are accessing your files. When we talked about file sharing in Windows, and we were able to share out folders or files, this is how we did it. It's using SMB, server message blocks. Finally, the last one I want to talk about is the Lightweight Directory Access Protocol, or LDAP. It's used to access and maintain distributed directories of information, like used on Microsoft domains. So, for instance, when you log into your Microsoft network at work, it is using an LDAP protocol. when you log in, that is what keeps the directory working. That's what allows you to authenticate. So Microsoft refers to this as a directory service. LDAP is also what's used to have a global address directory list in Exchange. So if I have an email system, LDAP is what allows me to keep sort of a big address book of everyone in the system. In other words, it allows you to use your username and password on the network. So LDAP really responsible for using your username and password on the network. That's how I want you to remember it for purposes of this exam, or when you see the word directory service. So now we've additionally discussed about DHCP for dynamic IP addresses, SNMP for management, SMB, which allows file sharing, and LDAP, which allows usernames, passwords, and directory services. Let's go back over these all again. We talked about ports, the logical endpoint of a connection. Then we looked at TCP, which is connection-oriented, like a delivery confirmation. UDP, which is connectionless. Then we looked at some protocols. FTP uses 20 and 21. It's the file transfer protocol. It allows you to transfer files. SSH 22, the secure shell, which is used specifically for securing connections between two computers, and can allow for secure file transfer as well. Telnet, which allows remote access to computers via the command line. SMTP, sending email. DNS 53, domain name system, which allows google.com to become an IP address, yahoo.com, whatever. HTTP 80, which is what's responsible for web browsing. POP3 uses 110. It allows you to download your email when you receive it. IMAP, which uses 143, as opposed to POP, allows you to organize messages on the server. Okay, so it's more advanced than POP. HTTPS, which uses 443, secure browsing. And RDP, remote desktop, as though you're sitting at it. Then we also discussed some additional protocols, including DHCP, which allows dynamic IP addressing. SNMP, which is for management of devices. SMB, which allows file sharing and print sharing, actually. And LDAP, which is directory services, basically what allows you to use usernames and passwords. So now that we've discussed how everything works logically, let's talk about how you even get out to the internet in the first place. What kind of services provide you internet access?